Hey Royals, we're going to start a new unit today. The unit is titled Energy. So our first lesson looks at the introduction of energy. And we're going to start by asking ourselves, what the heck is energy? So if you went to the back of your textbook, it will give you the definition of energy as the ability to do work. Now in physics we have a specific definition for work, and that will be left for another lesson. But in a short form, work is a force applied over a distance. So up to this point we've talked about motion, we've talked about forces, and so now we're actually going to put these into action and use them for other contexts, such as energy. Okay? So there's three types of energy if you look at them as an umbrella of terms. The first one would be potential energy. So these are the types of energies that would be formed in stored energy or by position. Now I have a couple of demos to show you to kind of show you some of the different types of potential energies. The first one, now I'm going to use this ball to demonstrate the first one. Okay, so at this position, the ball has a specific height off the floor of my house, but at this other position, it has a different height associated off the floor of my house. Now, based on these positions, there's a certain amount of stored energy, because obviously if I released it from a certain height, it will achieve a certain speed before it hits the ground. But if I were to lift it to a higher height, it would achieve a faster speed before hitting the surface of the earth or the floor of my living room. Okay, so this would be what we define as gravitational potential energy, due to the fact that force of gravity is acting on it and gravity influences how fast this object moves. Okay, the second one is shown in this glow stick. Okay, so inside the glow stick there are two different types of chemicals, and when they are connected by you breaking the glow stick, there we go, the two chemicals come together and they form a unstable molecule. This unstable molecule has the electrons go up into an excited state, and as the electrons come back down to their ground state or lowest energy, they release this energy in the form of light. Now the light, this energy is picked up by a dye, and you see it as this glowing on the glow stick. Okay, and so we call that chemical energy. So it's energy stored in bonds of molecules. Okay, so up to this point we've had gravitational potential energy due to height. We've had chemical potential energy due to stored energy in bonds. The next one we're going to talk about is elastic potential energy. So elastic potential energy, I've brought here my toy bow and arrow. At this point right now, the arrow is not going to be launched. However, if I connect it to the spring or this elastic here and I pull it back, I'm storing energy inside the elastic. So at this point, it is what I call as elastic potential energy, because it has the potential to do something. Because if I release it, it's going to shoot the arrow. Okay, so that's a stored energy inside a material that is able to either compress or stretch. Okay, the next one is what we call electrical energy. So electrical energy is due to charges. So in grade 9 and grade 10 science, you'll have noticed that there was an electron, there's a proton, and there's positive charges and negative charges. And these actually have a stored energy between them. So if you brought two positive charges together, you can feel the resistance between them. So it would be essentially if you brought two positives nice and close to each other and released, those two positives would go flying apart. So I'm going to try to demonstrate this potential energy. So in the balloon, there is no energy. There is no stored charges. So I'll do the whole, rubbing it on your head and see if I can give this balloon some energy by sticking it to the wall. Well, didn't really work. So I'm going to call my wife in and see if she can help me out with this. All right, let's try that again. And as you can see, because the balloon is now charged, it's attracting the hair.
My hair's charged too.
I know. So we've talked about 4 different types of potential energies. Now these are not all of them, but these are some of the different types of potential energies that you might observe. So there was gravitational potential energy due to height. There was chemical potential energy due to the bonds inside molecules. There was elastic potential energy with my bow and arrow, and then there was electrical potential energy in charges. Okay, so let's move on to the second type of energy. This is what we refer to as kinetic. So it's associated with objects that are in motion. So the first one you might notice is something called electromagnetic radiation. Now, that's a big term for anything that is on the electromagnetic spectrum. So visible light is on that spectrum. So the energy associated with the waves here gets seen as, to us, as visible light. Now you also would have, say, X-rays or gamma rays. These are objects that have energy, and it's energy in motion. Okay? Now there is also energy in what you're hearing right now, sound. Sound is moving particles that move around and cause your eardrum to bounce back and forth. They transfer that energy to your eardrum and allow you to hear things. So another form would be if you rubbed your hands together, you feel something called thermal energy. Now that's the molecules moving around. They move a lot faster as they warm up, and these are what we call as thermal energy, and that's the energy of motion. Now the last one that I'll talk about in kinetic energy is bulk kinetic energy. Now that's with particles that you might find for large objects, so objects that we can actually hold, and if they are moving, that's what we refer to as kinetic energy or bulk kinetic energy. So it's a large object that is moving along the surface or through the air. Okay, so there's three different types of kinetic energy that we just went over. The last major topic for energies or different types is something known as the rest mass. This is energy associated with mass. And you're like, wait a second, that sounds odd. Now you may have heard of an equation. This equation, I will be kind of shocked if you have not heard it. E is equal to mc squared, which was one of Einstein's famous equations, which says that energy is associated with the mass times the speed of light squared. So this will leave for a future course, but as you can see, that energy can be associated with mass. Okay, so energy, as we will say, cannot be created nor destroyed. It just transfers from one form to another. So I'll show you an example of what I'm talking about here. In my pocket of my hoodie, I have two AA batteries. Inside these AA batteries, we have what we refer to as chemical potential energy, because there's two chemicals inside the battery and they are actually stored there. The batteries can't do anything until the two terminals are connected. Okay, so what I'm going to do is I'm going to pull out a flashlight. I'm going to take the lid off. I'm going to throw my batteries into the flashlight, and still it's not doing anything. It's not turned on. This chemical potential energy is still stored there. It has the potential to do something, and it's not until I press the button on the end of my flashlight that I actually in fact get light. So where does this light come from? Well, the chemical potential energy is transferred into electrical kinetic energy. These are electrons moving along the wiring inside the flashlight. Now they get to the light bulb, where they turn into thermal energy, heating up the filaments inside the light bulb up to a point where that thermal energy creates light. They get so hot that they change into electromagnetic radiation, which is the light that we actually see. So you can see that it was not a one-step process of chemical batteries goes to light. No, the energy was transferred along through different forms of these types of energies that we've talked about in order to cause light to turn on. So that is an introduction to our energy unit. In the next lesson, we're going to talk about work. And then from there, we're going to take a deeper look at these potentials and kinetic energies, actually put some equations to them, and then move on with the rest of our unit. Again, if you have any questions or concerns or anything, please don't hesitate to reach out to myself or Mr. Woodyard. We're happy to help.